Good day, everyone. As a consultant of the global construction chemicals industry, I'm here to talk about the true value of crystalline technology in reducing life cycle costs of concrete structures. Owners and designers often focus on upfront costs, but over 50% of construction spending actually goes into maintenance and repairs. Every leak, crack, and patch can snowball into major expenses over a building's life. We want to break that costly cycle. How? By designing durability from the start, exactly what crystalline admixtures enable us to do. Before diving into economics, let's remember why this is needed in the first place. Concrete cracks. All the time. Even brand new, code-compliant concrete will crack, and that's normal. Is cracking in concrete inevitable? Yes, the codes say so. It may sound counterintuitive, but every experienced engineer knows that some cracking is expected in reinforced concrete. Our design standards openly acknowledge this. For example, ACI 318 commentary notes that visible cracks will develop under service loads and that crack widths will be widely scattered, influenced by shrinkage and other time-dependent effects. In other words, even with proper design, we should expect hairline cracks in service. The FIB Model Code 2010 echoes this reality, stating that cracks do not, per se, indicate a lack of serviceability or durability. In reinforced concrete structures, cracking may be inevitable due to tension, bending, shear, or torsion, without necessarily impairing serviceability or durability. Even European codes build in allowances for cracks. Eurocode 2, EN 1992-1 assumes that if we limit crack widths to about 0.3 millimeters under normal use, the structure's durability and appearance will be acceptable. So the truth is, we design concrete to crack, but only in a controlled, fine pattern that is not deemed harmful. ACI, Eurocode, FIB, all agree that cracking is inevitable in reinforced concrete. Now, why do these hairline cracks matter for life cycle costs? Because cracks are the paths by which water, chlorides, and other aggressive agents get deep into concrete. And once they do, they trigger corrosion of steel and other deterioration mechanisms, which are the real budget killers for owners. A tiny 0.2 or 0.3 millimeters crack can allow water to reach the rebar, start rusting, and before long you have spalling concrete and costly repairs. Traditionally, that meant extra rebar, thicker covers, external membranes, etc. Today, we have a far more elegant solution: crystalline admixtures that turn the concrete itself into a self-healing, watertight material. The self-healing solution, crystalline admixtures. Crystalline waterproofing admixtures are a game changer for concrete durability. Added directly into the concrete mix, they enable concrete to heal its own cracks and prevent water ingress. The technology uses the concrete's natural chemistry. Whenever water penetrates, the proprietary chemicals react with water and unhydrated cement particles to grow insoluble crystals throughout the pores and cracks. These crystals block the pathways for water. In effect, the concrete becomes its own waterproof membrane. This action is not a one-time event. It's permanent and reactivates whenever moisture is present, so it continues to self-seal new cracks even years later. Some crystalline technology reacts with water to form insoluble crystals within the concrete, blocking water pathways and self-sealing any future cracks. In practice, that means if microcracks form, any incoming water triggers crystal growth to plug them. Manufacturers of these technologies, Zypex, Penetrin, Schaumburg, and others, report that their admixtures can self-heal cracks on the order of hundreds of microns. For example, Zypex documentation shows it has the ability to self-heal static cracks up to 0.4 millimeters. Schaumburg's crystalline products likewise heal typical static cracks up to 0.4 to 0.5 millimeters. Think about that for a moment. 0.4 millimeters is the crack width many codes consider a maximum limit for durability. We now have concrete mixtures that literally heal such cracks on their own within days or weeks as water enters and initiates crystallization. The result is that water and harmful chemicals are kept out of the concrete matrix. It's like having a health monitoring system in the concrete that automatically treats the wound of a crack before it can cause a serious infection of corrosion. This self-sealing action has been verified in numerous lab tests and real projects. Of course, it's not just about healing cracks. Even uncracked concrete benefits from reduced permeability. Crystalline admixtures fill the inherent porosity of concrete with crystal growth. Independent studies show marked reductions in water absorption and permeability. In fact, a review of many tests found that hydrophobic and crystalline admixtures can cut water absorption by up to 80%. Air permeability, which correlates with how easily aggressive agents penetrate, can be reduced by 55%. In one study, adding a crystalline admixture reduced concrete's water absorption rate and air, significantly slowing moisture ingress. The concrete becomes denser and drier and stays that way throughout its life. By keeping water out, we effectively starve the corrosion process of its primary ingredient. The steel reinforcement stays passive, non-corroding. Far longer and deleterious processes like alkali silica reaction or freeze-thaw are also mitigated because the internal concrete isn't cycling with water. All of this directly translates to longer service life and lower maintenance costs. Life cycle cost benefits. Prevention pays off. Now, let's connect this to life cycle economics. There's a famous principle in our industry known as de Sitter's Law of Fives. W.R. de Sitter observed that if you delay investing in durability and maintenance, the eventual repair costs multiply dramatically. In his words, if maintenance is not performed, then repairs equaling 5 times the maintenance costs are required. In turn, if those repairs are not effected, then renewal expenses can reach 5 times the repair cost. This is often illustrated as $1 of prevention avoids $5 of routine repair, which in turn avoids $25 of major rehabilitation later. It's a compounding effect. Neglect leads to exponentially higher costs. We see this all the time in concrete structures. A cheap waterproofing solution used during construction might result in costly injections and patching a few years down the road. Ignore those, and you're looking at rebuilding whole sections later. Crystalline technology essentially flattens that cost escalation curve by addressing deterioration at the earliest stage, inside the concrete itself. It's a preventive measure at the time of construction, exactly where $1 spent has the most impact. By healing cracks and preventing ingress, we avoid the need for many repairs altogether. Even when repairs or touch-ups are needed, they tend to be far less extensive since the damage is shallow or localized rather than widespread. Let's frame the economics clearly. A crystalline admixture will typically add maybe 2 to 5% to the upfront concrete material cost, on the order of a few tens of dollars per cubic meter. In many cases, this is offset by savings in other areas. For instance, you might eliminate external waterproofing membranes or reduce labor and scheduling costs, meaning little net increase in initial budget. But even if it were a pure add-on cost, the return on investment over the structure's life is substantial. Consider a real-world case study. A large water reservoir project analyzed the life cycle impact of using a crystalline admixture. The treated concrete showed a 167% improvement in chloride diffusion resistance, significantly slowing corrosion ingress, and an estimated service life extension of 17 years beyond the original design life. The life cycle cost analysis found that this extended longevity and reduced maintenance translated to a 12-fold payback on the cost of the admixture. In other words, every $1 spent on the crystalline additive yielded about $12 in savings over the life of the structure. That is a 1,200% ROI in financial terms, an extremely sound investment by any standard. This isn't an isolated result. Around the world, owners of facilities like parking garages, water treatment plants, tunnels, and basements have seen major long-term savings by adopting integral crystalline waterproofing. By preventing water ingress and corrosion, they avoid the cycle of constant patch repairs. Many projects that used crystalline admixtures 20 to 30 years ago are still going strong with minimal maintenance, whereas similar structures without such technology have required major rehabilitation. The industrial leaders of crystalline technology like Zypex, Penetrin, and Schaumburg all have published case studies of structures from marine piers in harsh saltwater to high-rise building foundations that remain essentially dry and durable, with significantly lower life cycle costs, thanks to crystalline technology. Furthermore, this approach aligns perfectly with modern design philosophies like ISO 15686-1:2011 on service life planning, which encourages architects and engineers to design for a predictable service life and to consider whole life costing in decision-making. ISO 15686 emphasizes anticipating maintenance needs at the design stage and selecting durable solutions that minimize disruption over. It even notes that maintenance costs can reach about 3% of a building's capital cost per year, and that increasing durability is key to reducing these expenses. Investing in a self-healing concrete system is exactly the kind of strategy the ISO standard advocates. It tackles durability upfront to avoid unmanageable maintenance down the line. In short, crystalline admixtures operationalize the ISO's whole life cost approach, ensuring the structure achieves or exceeds its intended service life with fewer interventions. Crystalline admixtures significantly reduce life cycle costs by preventing water ingress and proactively managing cracks through self-healing. As the old saying goes, build it right the first time. By infusing a crystalline solution into our concrete, we build it right, such that it stays right for decades. The true value is that a relatively small upfront investment yields massive long-term savings and durability gains. This is a message owners and project stakeholders are happy to hear. We can protect your structure and your budget at the same time.